The most important line on this planet is the coastline. We kind of take it for granted. We act as if it's always been there and always will be. And it's understandable because for all of human recorded history, which goes back about 6,000 years, it hasn't really moved. But things are changing now, and we need to see the new reality. We need to separate the fact from the fiction, because the shoreline is a really important line. And somehow we mess it into politics and emotions and beliefs, but this is about as physical as it gets. All over the world, glaciers are disappearing, from Alaska to the Alps, from Greenland to Africa's Mount Kilimanjaro. This is reality. The ice is melting, the sea level is rising, and the shoreline has just begun to move inland. And it's all happening because the Earth is 1.5 degrees Fahrenheit warmer than it was just a century ago. And ice melts at 32 degrees. It doesn't care whether you're Republican or Democrat. Florida, I give talks all over the world, but Florida actually is one of the best places to really visualize what's the relationship between sea level and the shoreline. We know what Florida looks like today. It's an iconic shape, and because it's a very low elevation, it actually responds very quickly to long-term changes in sea level. If we look back 20,000 years ago, during the last ice age, sea level was down hundreds of feet lower, and Florida was twice as big. And conversely, if we were to go back 120,000 years ago, to the time in geologic history when we were at the last warm spot, Florida was half the size when sea level got just 25 feet higher than today. Dramatic changes. So we need to understand what's happening. The difference between those two states, that was a natural heating and cooling cycle that we call the ice ages. It happens about every 100,000 years. It's been going on for millions of years. You probably learned something about the ice age, but I'd like to refresh your memory. I won't let it get too technical. Maybe you saw the 4-part scientific series, particularly part 2, Ice Age, The Meltdown. While it was an animated cartoon, it's actually reasonably accurate for what happened during the last ice age. My daughter was 6 at the time this came out. I watched this dozens of times. And behind Manny, Sid, Diego, Scott, and the other creatures there, I'll tell you about them later, there's 2 miles of ice, 10,000 feet of ice, and it melted over about 15,000 years. And that 10,000 feet of ice turned into almost 400 feet of rising sea level. And it got to the present level just about when we really got our stuff together and began keeping written records. Really the dawn of our civilization 5,000 or 6,000 years ago. So that's why we have trouble believing it'll ever change. It makes sense that every time sea level goes higher, the shoreline is going to move inland, but the ratio is surprising. For each foot of rise, the average global shoreline moves inland about 300 feet, the length of a football field. And here in flat Florida, that ratio is even higher. The increase in sea level happens in different ways. Sea level normally changes very slowly. We're used to events that do sudden damage, like Hurricane Sandy a year and a half ago, that also illustrated how a large storm, if it hits at an extreme high tide, does even more devastating damage. We understand that. The other phenomenon we're starting to see is flooding streets on a regular basis, every 28 days, along with the lunar tide cycle. Flooding streets without rain, without storms. And in some neighborhoods, there are actually storm drains installed that were designed to take excess rainfall and move it over to the nearest waterway. Those storm drains now work in reverse every month, and some months worse than others, depending upon the alignment of the planets. The salt water is backing up through the storm drain. It's happening from Key West and in Broward County and up toward Palm Beach County and out in Seattle, all over the world. low-lying coastal areas. That didn't happen a few decades ago when those streets were designed like that. Something's changing. We're not noticing it. This is a house that's in one of those neighborhoods. I don't know if you can see it, but underneath the for sale sign, there's a little red accent sign that tells us it's waterfront property with a pool. Good to know. We need to look at some facts and also identify some fictions and misunderstanding. The polar ice cap is not why we're getting sea level rise. That's floating ice. And like ice cubes in a glass, protrude 10% over the water. And as they melt, they do not add to the level of liquid. You have to add ice or add liquid to get the level to rise. The same for the ocean. What it does prove, the disappearance of polar ice cap, which has been frozen for 3 million years, and it will be ice-free starting in September in the next few years, certainly within 20 years, is that we are in a new era. And trivializing it and making it political and pretending it's not going to happen is not going to do any good. There's enough ice presently on Greenland and Antarctica and in the glaciers of the world to raise sea level 212 feet. Now, don't panic. It's not going to happen this century, and it won't happen next century. We don't know whether it'll take 300 years or 3,000 years. We're running the experiment now. You're all part of it. It's not a really good experiment, but we're doing it. If we look at the long-term trend of sea level, it goes up and down in a regular pattern, left to right, 400,000 years. That shows us 4 ice age cycles. If we add graphs in red for temperature, global temperature, and green for greenhouse gas, carbon dioxide, we see an amazing thing. Those 3 lines move together. There is a regular pattern. They go up and down within normal bounds for millions of years. The problem is in the upper right-hand corner, the straight vertical green line that says that carbon dioxide has broken out of the 180 to 280 parts per million and is now at 400 parts per million. Yes, we need to do those great energy technologies that you've seen earlier today here at TEDx. We should try and conserve energy and do amazing things, but we need to deal with the reality that there's enough extra heat already in the ocean that the ice is going to keep melting for centuries. We can slow it, but we cannot stop it. It's different than the storm surge, which recedes in days, and the extreme tide, which recedes in hours. Rising sea level will not recede for centuries, even if we do the right things with energy and green and sustainability. We've got to get rid of that fiction. We need to do both. We need to adapt to rising sea level. It's now inevitable. We should do all the right energy things to try and slow it. But we need to move our shoreline inland. We need to adapt to the reality that after several thousand years of stability, the shoreline is moving. If we look at the recent trends of carbon dioxide, temperature, and sea level, we see the 3 lines continue to move together. And they will. We should do the right thing to slow it. How do we know that data? It's locked in the ice cores. We can drill down in the ice and get layers going back 800,000 years, similar to the way we drill into a tree and get tree rings. We can date the layers of ice to within 3 years. In the air bubbles are the data. It's a great technology. What does this mean for us today? The truth is it changes everything about our world, not the world of electrons and the world of art and all the other things you've seen this morning, but it changes our physical world. It changes where we live. And not only that, where our children will live and our grandchildren and beyond. This is not pretend, and electron technology will not solve it by itself. We have to adapt to a shoreline that is shifting inland for the first time in human civilization. It can be depressing, it's sobering, but here's 3 positive ways to look at it. I sometimes like to talk about it as the glass half full after we look at the glass half empty. But this glass is going to get higher each decade. First of all, compared to the normal disasters like tornadoes, tsunamis, and earthquakes, and even big storms, we have plenty of warning with this one. This is unstoppable, but we can see it coming. We have time to adapt. The second is, we do great things when we're challenged and we focus ourselves. Putting man on the moon, cell phone technology, medical cures. We need to focus on this. Not only the energy and slowing the warming, we need to start adapting. There will be great opportunities. Crisis equals opportunity. Those that can see the future will not only survive, they can thrive. The third is we need to begin to share this for not only us, but for our children and for future generations. And so my idea is that you help explain to people that the ice is melting, the sea is rising, and the shoreline has just started to move inland. We have time to adapt to a moving shoreline, but we have no time to waste.